Hi, welcome once more to Mr. Max. In this lesson, we are going to revise from February-March 2018 question paper, February-March 2018 probability section. So please make sure that you download this question paper from our app or go to Department of Education website. From there also you can download the question paper. Okay. So anyway, it is better to have a question paper with you. So when I explain, you can read the question also. Okay. Okay, without wasting time, let's start. Probability is question number 11.1. What is the first question? Veli and Bongi are learners at the same school. So there are two learners. One is Veli and the second one is Bongani. Okay, so there are two learners there. One is Veli and the second one is Bongani. Okay, these are the two learners, and we can represent that Veli with V and Bongani with let's say B. Okay, so there are two learners, Veli and Bongani. We represented Veli with V and Bongani with B. Okay, now some days they arrive late at school. The probability that neither Veli or nor Bongani will arrive late on any day is 0.7. Probability of neither Veli nor Bongani will arrive late on any day is 0.7. What is the meaning of that? Neither nor. It means that not Veli, not Bongani will arrive late. Okay. So both are on the correct time. That is the meaning. Okay. So probability of neither Veli nor Bongani. It means that not Veli or Bongani. Am I right? Neither Veli nor Bongani means that not Veli or Bongani. Okay. What is or in terms of probability? Or how can we represent? You know, in theory class I told you, or we can represent as union and we can represent as intersection. Do you remember that one? Okay, or is union and is intersection. Okay, so here what or? So it means that one is actually that one is stands for union. Okay, this one is union. Then not. What is the meaning of this one? How can we represent in probability? Not means in complement events, when you study theory, I told you probability of A complement. How can you write? Probability of A complement is the same as probability of not A. Probability of A complement, what is the meaning of that? Not A. So probability of not A is the same as probability of A complement. Okay. So probability of not Veli union Bongani, that is the same as, how can I write that one? This one is the same as probability of Veli or means union. Veli union, this is V, this one is V, this is U. Bongani complement. Okay. No, probability of A complement is probability of not A. So probability of not A is the same as probability of A complement. So probability of not this one is the same as probability of. Okay, let me write for you to understand more clearly. So I told you not is the same as complement. Okay, not A is the same as A complement. Okay, so how can we write this one? Probability of Veli, we represented Veli with V. Okay, or is the same as union. Okay, Bongani, then complement. Okay, why it is complement? Because it is not. Okay, and it is given in the question that probability of that neither Veli nor Bongani, that's why we put a complement. Okay, will arrive late on any day is 0.7. So the probability of this one is 0.7. Okay, now what is the first question? 11.1.1. 11.1.1. What is that question? Calculate the probability that at least one of the two learners will arrive late on randomly selected day. So you have to find the probability of at least one of them, at least one of the two learners will arrive late. You have to find the probability of at least one of them will arrive late. What is this one? Not arriving late. This is not arriving late, and you have to find the probability of at least one of that two arrive late. So it means that what is probability of A complement equation? How can we write this one? That formula, probability of A complement is the same as 1 minus probability of A. Am I right? Okay. Similarly, this probability of V union B complement, how can we write? 1 minus, this is the same as 1 minus probability of V union B. Am I right? Probability of A complement is the same as 1 minus probability of A. Probability of V union B complement, that is the same as 1 minus probability of V union B. Compare these two. Okay, and that is given as 0.7. Okay, and what's the question? We have to find what is the probability that at least one of the two learners will arrive late. Will arrive late means this one, probability of what is that? Valley Union Bongani. Arrive late. What is given? Not arriving late is 0.7. So you have to find, in this question we have to find what is the probability of arriving late. Arriving late means you have to find probability of V union B. Okay, so how can we find from here? Take this 0.7 to this side, so it is 1 minus 0.7 is equal to, take this one to the other side, so it is positive probability of V union B. So 1 minus 0.7, you can check in your calculator, 0.3 is equal to probability of Valley Union Bongani. So it implies that probability of Valley and or Bongani being late is 0.3. So don't be confused. Probability of Valley or Bongani not being late, neither Valley nor Bongani will be late, is 0.7. That is how can we represent Valley union B Bongani complement. So probability of A complement 1 minus probability of A. So like that we can write it like this. Then from there probability of being late we can find, that is 0.3. Okay, that is question number 11.1.1. let's go to question number 11.1.2. question number 11.1.2. what is that question? The probability that Valley arrives late for school on a randomly selected day is 0.25. So the probability of Valley arriving late. Okay, so before I go to that question, what is the answer we got? Probability of Valley Union Bongani 0.3. Okay, Valley Union Bongani we got from the previous question, it is 0.3. Okay, now come back to this question 11.1.2. the probability that Valley arrives late for school on a randomly selected day is 0.25. so how can we write probability of Valley arriving late? Okay, that is 0.25. Then what else given? While the probability that both of them arrive late for school on that day is 0.15. What is the meaning of that? Both of them arrive late. Probability of both of them arriving late is 0.15. How can we represent both of them? Both of them means what? Both Valley and Bongani. Look at that word. Both of them means Valley and Bongani. And how can we represent? And is the same as intersection. Am I right? So in effect, it is given that probability of Valley intersection B, probability of both Valley and Bongani being late is 0.15. Okay, and what is the question? What do you want to find? If it is like that, okay, Calculate the probability that Bongani will arrive late for the school on that day. So it means that in this question you have to find the probability of Bongani will, what is the probability of Bongani will be late. So how can you find that one? Okay, so try to understand like this. In grade 11 you studied a addition formula. Okay, one famous addition formula. The formula is like this: probability of A union B. Do you remember the expansion of this one? Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. You have to by heart this formula. This is a very famous formula. This is an addition formula in probability. Okay, so probability of A union B is same as probability of A plus probability of B minus probability of A intersection B. Okay, now here instead of this A and B, we have V and B. Oh, what is that? Valley. Yeah, Valley and Bongani. Okay, so how can we write that one now? This is the standard formula we studied. Okay, so how can we write in terms of Valley and Bongani? Probability of Valley union Bongani is equal to probability of Valley plus probability of Bongani minus probability of Valley intersection Bongani. Valley intersection Bongani. Okay, so what is this probability of Valley union B union Bongani? The previous question we got the answer for that one. Probability of Valley union B is 0.3. Okay, so we can substitute that one. So it is 0.3 is equal to probability of Valley. It is given in this question, that is 0.25. So 0.25 plus probability of Bongani. That is what we want to find. Am I right? We want to find probability of Bongani. Okay, so leave that one as it is, minus probability of Valley and Bongani common intersection. What is that one? 0.15. Okay, so from here we have to find the value of probability of B. Take all these numbers to this side. So it is 0.3, it's already there. Take this 0.25 to this side. So it is minus 0.25. Take this one to this side. Here it is minus. So on this side it is plus. So it is plus 0.15, and that is probability of Bongani. We took already we took these two to the left side. So remaining is this probability of B. So take your calculator, try to find the value of that one. In your calculator, you will get the answer. Let me check 1 second there. Okay, 0.2. So in your calculator, 0.2 is equal to probability of Bongani, or probability of Bongani is equal to 0.2, and that's the answer of question number 11.1.2. Okay, let's go to 11.1.3. question number 11.1.3. The principal suspects that the late coming of the two learners are linked. So there is a connection between, the principal is suspecting that there is a connection between the late coming of these two learners. Okay, maybe both of them going somewhere else. Okay, that's what principal thinking. Okay, anyway, the principal asks you to determine whether the events of Valley arriving late for school and Bongani arriving late for school are statistically independent or not. So don't forget that you are a maths student. Okay, so now the principal is asking you, okay, try to find statistically, okay, or using the probability, try to find is there any connection, or is Bongani and Valley being late is independent or dependent. Okay, is there any connection? Connection means dependent, or independent means there is no connection. Both are because of different reason. Okay, so principal is asking you statistically try to find is the probability of Bongani and Whaley being late is any connection, or is it independent or dependent? Okay, so how can you find? Now leave the story of principle and all the things. Okay, we have to know what is the condition for what is the condition for independent. How can we prove that two events, for example A and B, are independent or not? Okay, so what is the condition for that? If two events being independent or not, the condition for that one, the A and B. So condition is probability of A intersection B is equal to probability of A times probability of B. This is the condition to find that we can use two events A and B are independent or not. Okay, so how can we find two events A and B are independent or not? We have to find probability of A intersection B. Okay, then we have to find what is the answer of probability of A and probability of A times probability of B. If the left side and right side are equal, then we can say that A and B are independent. If it is not equal, then we can say that it is dependent. Okay, so in our case, it's not A and B, it's Whaley and Bongani. That is only difference. Okay, this is a general notation. If two events A and B are independent, then this equation must satisfy. Okay, so let's try to find in our case. Our case, it is Whaley and Bongani. So probability of Whaley intersection Bongani, first we have to find. Okay, let's try to find that one. Probability of Whaley intersection Bongani. Is it not that we given in the previous question? Probability of Whaley intersection Bongani 0.15. It is given in 11.1.2 question. Okay, so it is given in the question that the probability of Whaley intersection Bongani is 0.15. Okay, now let's try to find probability of Whaley times probability of Bongani. So probability, okay, this is equation number 1. Now let me try to find, or let me do it like this. Instead of writing equation number 1, let me write it like this. LHS is equal to probability of A intersection B, not A and B, it is Whaley and Bongani. Okay, so it is probability of Whaley intersection B, and that is 0.15. Okay, so we got the left hand side as 0.15. Now let's take the right hand side, RHS. Okay, so that is probability of A times probability of B. So in our case, probability of Whaley times probability of Bongani. What is probability of Whaley? Probability of Whaley is previous question 0.25. Am I right? Okay, so 0.25 times probability of B, Bongani, we already found, that was the question 11.1.2. we got the answer as 0.2. okay, so 0.2. so check in your calculator, 0.25 times 0.2, so it is 0.05. 0.05. So here look at these two answers. What is the left hand side? 0.15. And what is the right hand side? 0.05. Are they equal? No, they are not equal. So what is the meaning of that? It is not independent. Okay, so it implies that probability of Whaley intersection Bongani is not equal to probability of Whaley times probability of Bongani. So what is the meaning of that? It implies that the late coming of, what is the question? What is that word? Determine whether the events Whaley arriving late for school and Bongani arriving late for school are statistically independent or not. Okay, so it implies that probability of being Whaley arriving school and Bongani arriving school are not independent, or we can say that it is dependent. Okay, so you must have to write that sentence, not independent. If that word, even though you write the full story, you have to write the full story, but that word must be there, not independent, because 1 mark is for that one, independent or not independent. Okay, so you have to write probability of Veli arriving late and Bongani arriving late are not independent. You must have to write that word. Probability of Veli arriving late and Bongani arriving late are not independent. Okay, so that is question number 11.3. Now let's go to question number 11.2. 11.1.3. Now let's go to 11.2. Okay, question number 11.2. 11.2. What is that question? The cards below are placed from left to right in a row. So there are some cards there. Okay, look at that picture. It is very important. It's difficult for me to draw here. Okay, so that first one is a diamond, second one is a heart, again diamond, again heart, diamond. So how many diamond cards are there? How many diamond cards are there? 1, 2, you can count 3. There are 3 diamond cards. And how many heart cards are there? 1, 2, 3. So there are 3 diamond cards and 3 heart cards are there. Okay, fine. The cards below are placed from left to right in a row. So it is arranged in a row like this. Okay, now first question, 11.2.1. 11.2.1. In how many different ways can these 6 cards be randomly arranged in a row? So you have to find in how many different ways these 6 cards can be arranged. So how can you find? So how many cards are there? 6 cards. Okay, so let me write 6 spaces here. This is 6. Okay, so these are my cards. Okay, these are my cards. These are my cards. Okay, so this first card can go here. Okay, am I right? So it's here. So now before that, okay, let's think like this. This one, for this position, I want to put a card here. Okay, so how many options I have? I can take any 6 cards because there is no condition given. Look at that question. In how many different ways can these 6 cards be randomly arranged? There is no condition. Okay, so this position I am supposed to put a card here, here like that. Okay, so in this position to be filled, how many options I have? How many cards with me? 6 cards. Okay, so I have 6 options there. Okay, so I took one card and put it there, any one card. Okay, let's say I took this card, I put it there. Okay, now for this position to be filled, how many options I have? Now it's how many cards left? I have only 5 cards. Am I right? So this position to be filled, I have only 5 options. Okay, so assume that I took any one card and put it there on the second place. Okay, so now how many options I have? Only 4 options. So it means that to put this space, to fill this place, I have only 4 options. Take the one card. So remaining how many? Okay, let's say take this card. Okay, remaining how many cards? 3. So this position I have only 3 options. This position I have only 2 options. This position I have only 1 options. Okay, so total 6 times, 5 times, 4 times, 3 times, 2 times, 1. That means this is the same as 6 factorial. We studied in theory. Okay, 6 times, 5 times, 4 times, 3 times, 2 times, 1 is the same as 6 factorial. So take your calculator and try to find the answer of 6 factorial. It is 720. So this one is 720. That means in 720 different ways we can arrange that 6 cards. Okay, let's go to question number 11.2.2. 11.2.2. What is that question? In how many different ways can these cards be arranged in a row if the diamond and hearts are placed in alternative position? So you have to find in how many different ways these cards can be arranged in a row if diamonds and hearts are placed in a alternative position. Okay, so how many diamonds are there? There are 3 diamonds. How many hearts are there? 3. Okay, so in how many different ways it is possible to arrange diamond, heart, diamond, heart, diamond, heart, like that, or what, heart, diamond, heart, diamond, like that also is alternative position. Am I right? Okay, so it means that you have to write how many different methods. For example, diamond, heart. Okay, let's say H. This position. Okay, 3. How many cards? 6 cards. Okay, first diamond, then heart, then diamond, then heart, then diamond, then heart. Am I right? Okay, or which way we can look at this one? 6 cards. 1 2 3 4 5 6. Okay, so here I started with the diamond. Let me start with the heart. That is also alternative position. Okay, heart, then diamond, heart, then diamond, heart, then diamond. I can place like that also. Okay, now you must be careful. Okay, now look at this one. For this position to be filled, how many options I have? Diamond. How many diamonds are here? 3. That means I didn't take any card from that. That means for this position to be filled, I have 3 options. Okay, next, this diamond, I already took 1 diamond from there. So for this position to be filled, how many options I have? Only 2 options, because I already took 1 and put it here. Okay, now for this position I don't have any option, only 1 more card left here, because I already took 2 cards from these 3 diamonds. So it means that for this position I have only 1 card left. Okay, now heart. For this position to be filled, how many hearts I have? 3. Right, so I took 1 and put it here. Okay, now how many hearts are there? It's only 2. How many options I have now? 2 options, because there are 2 hearts. I took 1 and put it here, so remaining only 2 hearts. So here I have 2 options. Now how many hearts are there? How many hearts I took? Already took 2 hearts. That means only 1 more heart left. So here I have only 1 option. Okay, so same applies here. First one, heart, how many options? 3. For this heart, how many options? 2. For this heart, how many options? 1. For this diamond, how many options? 3, because there are 3 diamonds. Okay, for this diamond, how many options? 2. For this diamond, how many options? 1. Okay, so now what is the question? Look at the question once more. In how many ways can these cards be arranged in a row if the diamonds and hearts are placed in alternative positions? So how many different ways we can arrange according to this condition? Diamond, heart, or heart, diamond, like that. Okay, so in this way, okay, let me erase this 11.2.1. Now look at this one. Let's think about, so you are supposed to multiply this one. Okay, so actually we can write it like, there is no problem, you just multiply, you will get the same answer. Okay, let me write it like this. 3 times 2 times, I'm talking about this diamond, so it is 3 times 2 times 1, that is diamond. 3 times 2 times 1. Okay, then this heart, 3 times 2 times 1, so times 3 times 2 times 1, plus, why it is plus? Either this option or this option. Am I right? Okay, so here also heart, 3 times 2 times 1, and diamond 3 times 2 times 1. Okay, so here plus 3 times 2 times 1 times 3 times 2 times 1. So actually 3 times 2 times 1 is the same as 3 factorial. You studied that one. Okay, times again 3 factorial plus this one is also 3 factorial, this one is also 3 factorial. Okay, so 3 factorial into 3 factorial plus 3 factorial into 3 factorial. How many 3 factorials are there? there are two sets of 3 factorial, am I right? Okay, so this is the same as, I can write it like this also, 2 times 3 factorial times 3 factorial, am I right? There are two sets of 3 factorial times 3 factorial. This is 1, this is 2, am I right? So how can we write that one? This one is 1, this is 2, it is added. Okay, so it is, for example, let's say 5 plus 5. Okay, this is the same as 2 times 5, am I right? Because 5 plus 5 is 10, 2 times 5 is 10, am I right? Okay, so 3 factorial times 3 factorial plus 3 factorial, that is 2 times 3 factorial times 3 factorial. Okay, so check in your calculator what is answer for that one. In your calculator, it's 72. So calculator, you will get the answer as 72. Okay, you can check in your calculator. So that is question number 11.2.2. Now let's go to 11.2.3. If these cards are randomly arranged in a row, calculate the probability that all the hearts will next to one another. Wow, what is the meaning of that? All these cards, that means how many diamonds are there? 3. How many hearts are there? 3. Now they are saying that all that 6 cards are arranged in a row. Okay, now what is the condition? What you want to find? Calculate the probability that, you have to find the probability that all the hearts will be next to one another. All the hearts will be next to one another. What is the meaning of that? Okay, let's say 1, 2, 3, 4, 5, 6. These are the, okay. Now they are saying that all the hearts will be next to, that means this is a heart card, this is a heart card, and this is a heart card. Okay, so that 3 heart must be next to one another. That means that must be together, it must go together. Okay, and here the remaining is diamond. Here it can be diamond, 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 diamond. Okay, maybe some of you think things like this, since that 2 hearts are these 3 hearts are together, so the remaining 3 diamonds are together. It's not like that, because this diamond, only one condition for them, these 3 hearts must be together. So there is no problem for put this diamond here. Then also only this diamond we can put it here. So diamond, then 3 hearts, then 2 diamonds, or we can put these 2 diamonds here. Am I right? So 2 diamond, then 3 hearts, then 1 diamond. Okay, so don't think that since these 3 hearts are together, so definitely these 3 diamonds are together. No, it's not like that. This diamond you can put it here, this diamond you can put it here, or these 2 diamonds you can put it here. They just want these hearts to be together, that's all. Okay, so you have to find the probability of how many possibilities. Okay, so here when I taught that theory part, okay, those who didn't watch that theory part, you must have to watch. Okay, so this type of questions, when it is in a row, okay, and if they want to group something, you have to consider that as 1. Okay, listen very carefully. So I'm going to count like this: 1, these 3 as 1, 1, 2, 3, 4. Do you understand? 1, 2, 3, 4. Okay, that means what's the number we got? 4. Okay, so 4 factorial times. Okay, then now you have to think about inside this group, how many? 1, 2, 3. That means that is another times 3 factorial. So this is the possibility. Okay, what I said, this one you have to count as 1, 1, 2, 3, 4. That is 4 factorial times, then inside this box how many? 3 hearts. that is times 3 factorial. Okay, but here the question is, what is the probability, okay, of all hearts? So you have to write probability of all hearts will arrange next hearts will next to one another is, then this is the number of possibility in this case. Okay, but when you write your probability, when the question is to write the probability, you are supposed to write divided by total how many possibilities. Total how many possibilities, we erase that one. That was 11.2.1 question. Without any condition, what was answer there? 6 factorial. Do you remember that one? Okay, so without any condition, what is the probability? Total probability 6 factorial. That means divided by 6 factorial. Okay, so the probability of, look at the question, the probability, you calculate the probability that all the hearts will be next to one another, all the hearts will be next to one another is equal to, this is the number of possibilities in this case, all the hearts will be next to that, divided by total possibility. Total possibility is 6 factorial. So take your calculator to find the probability of this one. Okay, so try to find the answer of this one in your calculator. You will get 1 over 5. 1 over 5. Either you can leave it like this or write it in percentage or decimal, 0.2, okay, or 20%. Okay, so anyway the answer is 1 over 5. Okay. So that is question number 11.2.3, and that's the end of February March 2018 probability section. Okay, so guys, I hope you understand all these things, and hope you enjoyed. See you on next class. Okay, thank you.